Hello students, the topic of today's presentation is presentation of data. So myself Lubna Fatima, Senior Lecturer, Department of Public Health Dentistry, SRM Dental College, Ramapuram. So I'll be discussing on the data presentation. I mainly focus on the third year students. It's going to be a 15 to 10 minutes presentation. And yeah, I'm going to tell all the methods for data representation. So these are my contents. I'm going to talk about introduction, presentation of data, tables, types, and what are the types of tables present in the data. I'm going to represent in the form of graphs and then conclusion. So what is a data? Data is nothing but datum, which is derived from the Latin word. Data is something which is a raw information we collect in the form of numbers or facts or details. Whereas data representation or a presentation of data is you understand the raw information quickly and very easily because you represent in such a good manner. So data representation is nothing but it refers to the organization of data into tables, graphs or charts so that logical and statistical conclusion can be derived from the collected measurements. So first you collect the data and then what you do is you represent in a very easy form for the author or the reviewer to understand in forms of tables or graphs because it will come to a very easy conclusion and your logical derivation will be very good and representable. So these are the principles of data. It should be simple, meaningful and interesting. Concise without losing important details. Define problems and suggest solutions. Facilitate further analysis. The types of data representation we represent in the form of tables and graphs or charts. So tables, there are three types. It can be simple table, master table and frequency distribution tables. So how are these tables going to be? It should be clear, easy, labeling should be there, footnotes should be there, numbered here and there the numbers should be perfectly written and title for each description should be written. So this is one example of simple table. For example, if I'm going to go and do a research on the third year postgraduate students, if there are 70 postgraduate students in third years, then I'll go see them individually what is their DMFT score. So that time if I tabulate in this form the highest to lowest or something like in the form of that particular person's data, then this is going to be a simple table where I'm going to just name the individual name and I'm just going to give the DMFT score. Whereas frequency distribution is nothing but first I'm going to divide them into who and all have 1 to 7 as a score, who and all have 7 to 14 as a score, who and all have 14 to 21 as a score. So in some format I'm going to do as a frequency distribution and then I'm going to represent in the form of frequency table. How many? From 1 to 7 there are 2 individuals who have the such score. 7 to 14, 5 individuals have such scores. So I'm going to separate in that form. So that is going to be a frequency table. Master table. Master table is nothing but I'm not only going to see one variable, only DMFT, but rather I'm going to see n number of variables such as DMFT, OHIS, OHI, tooth loss, pockets, fractured teeth for that set of individuals. Then I'm going to represent in the form of master chart. So that is the difference between master table and a simple table. Simple table is nothing but one variable will be represented. Master table is more than 2 or 3 variables are represented. Then you will go for a master table. Next, moving on to graphs. So graphs, as I told you before, is going to be in a form of pictograph, pie diagram, bar diagram, line graphs, histogram, frequency polygon, scatter plot and catogram. Okay, so these graphs should be easy, clear, not clumsy. Labeling should be perfect. Axis should be shown, numbered and titles for each graph should be represented. The first, moving on to pie diagrams. So pie charts, as we know, it's going to be like a pizza. So how the pizza is divided into 8 or 6 or 4 pieces, like that you're going to divide this pie diagram into different pieces. So you use a pie diagram when you want to show how something is divided into parts. They are great for data given in the presentation or in percentages. This will be a very good sort of representation. Donut is nothing but if I am going to as I told you before, if I'm going to see a set of individuals, I'm going to see DMFT score. If I'm want to represent in the form of frequency as well as in the form of percentage, then donut will be one good or one very reliable diagrammatic format where I will be represented in both percentage and frequency distribution. Bar diagram. Bar diagram is nothing but it's going to use bar in the form of bars vertically or horizontally to show and compare data. This bar diagram is used to compare different categories of items. For example, if I am going to see whether how many people are consuming apple in between first year, second year and third year. Now this is going to represent if apple has three bar charts, that bars, then it's going to represent how many first years consume apple, how many second years consume apple, how many third years consume apple. So they will have a differentiation in the form of bars. Whereas multiple bar diagram is nothing but if I am, as I told you in master chart, if one individual, if I'm going to record DMFT, DMFS, OHIS, tooth loss, pockets and everything. So if that individual, how many DMFT score she has, or how many OHIS score she has. So I'm going to different in the form of multiple bar diagrams in one such variable. So it's going to be a multiple bar diagram format. Whereas proportional bar diagram is nothing but I'm going to name in the proportion where one single bar will have a division and they will be named in the form of proportion. Line diagrams is nothing but these line diagrams uses lines to show data changes over a time. If you're going to record over a period of time, then this line diagrams will be applicable. This uses a line graph when you want to track how something changes over different time cycles, whereas minutes, hours, days, etc. So next is if you want to do a line diagram, but you want to point where that actually dips or falls or where the score is actually defining that particular people, then this line with point diagram will be very helpful. This is multiple line diagrams where if you have a multiple variables like you represent in the master chart, then this multiple line diagrams will be helpful for you to represent the data in the form of for each and every individual with so many data representing and with a clear cut idea if you want to represent all the variables in a single diagram. Histogram is nothing but it is like a bar diagram or bar chart, but for numbers and ranges and not categories. See, if you are going to record for 5 years how much DEF score is there, for 6 years how much DEF score is there, for 7 years how much DEF score is there, then you will go for a histogram. Whereas if you're going to record from 1 to 6 years or 7 to ranges, if you're going to record in ranges, then this is not applicable for you. Okay. So if I am going to take in the form of heights 120 centimeters or 125 centimeters or 130 centimeters, I am going to represent in the form of histogram. Now next is histogram frequency where I am going to record from 1 to 7 or 7 to 14 or 14 to 21. I will be representing in frequency forms. So make sure that if you represent it in a single format, then you will go for this. And you represent in frequency format, then you will go for the frequency histogram where you will represent in the frequency distribution. Next is frequency polygonal where you are going to plot such a histogram and then you're going to connect the mid value and make as a frequency polygonal graph. Next is scatter plot. Scatter plot is nothing but if you want to analyze correlation between the two variables, then this scatter plot will be very helpful for you. When you have a large number of data and you're not able to plot any graph, then this scatter plot will be applicable for you. For example, correlation between two variables is if you're finding the correlation between dental caries and gender difference, then this plot will help you to analyze the data and help you to correlate between the variables. So scatter plot chart is like a collection of dots on a graph. Each dot represents something. We use it when we want to see if two things are related or not. So scatter plot help us to see if there's a connection between two things by looking at the dots are spread out or not. We are going to look it. So this scatter plot will be helpful for you to analyze correlation analysis. Pictogram is nothing but it's a special chart that uses pictures or symbols to show information. Now, till now we have used only numbers to show information, right? But in this we are going to use pictures or symbols to show information. So pictogram is nothing but it is also a cartogram. It's called a thematic map in which mapping variables such as if you want to know what is the distribution of fluorosis in Tamil Nadu, then you will make this will be very helpful for you to show the distribution of fluorosis in Tamil Nadu. Now these are my references. You can use our Shobhan Peter book and you can use Mahajan for biostatistics. Thank you.